working with solving systems of equations using the elimination method, but we're going to go ahead and make this just a little bit more difficult in terms of how to solve these. So really quick, we've gone through how to solve systems with graphing. Equations need to be in slope-intercept form. We graph them. Where they intersect is the solution graphically. We've done it with substitution, where we have one of the equations solved for a variable. We substitute in what that variable is equal to into the second equation, work it down. And then yesterday we introduced how to use the elimination method, where when we have both of the equations in standard form, we have either the additive inverse of one of the coefficients or the same coefficients for one of the variables. If they're additive inverses, then we go ahead and we add the equations together, and when they are the same, when the coefficients are the same, then we subtract the equations. Now today we're going to review quickly that and then talk about what happens or what we can do when we don't have that situation. So in example 1, go ahead and write this in your notebook. Actually in class we'll be watching a quick little video on this, but since we're not in class, you're going to work down through this with me in your notebook. So I've got these two equations. 5s plus 4t is equal to 27, and 3s plus 4t is equal to 31. That's a system of equations because I have more than one equation here. And if I look at the coefficients for s are 5 and 3, not the same or additive inverse. So I go on to t. Here I see that I've got a positive 4 and a positive 4. So here I see that they are the same. If the coefficients are the same, quick reminder, all I have to do is subtract. So I'm going to pull this subtraction sign here, and we subtract the coefficients of the same variable and the constants. So I'm going to have 5 minus 3. 5 minus 3 is just 2. Keep the s. And then 4 minus 4 is 0t. So plus 0t is equal to 27 minus 31. 27 minus 31 is negative 4. Okay, so it's important that we remember to always take it back to the subtraction sign in this case, or if we have additive inverses of these coefficients, if they're additive inverses, we would have added. But we always bring it back here, and if I'm ever in doubt, I can just come off to the side and say 27 minus 31. And this subtraction sign here is actually this subtraction sign. Okay, so that's where that comes from. So I've got 27 minus 31 is negative 4. This is now 2s is equal to negative 4, and divide both sides by 2. I think s is equal to negative 2. I'm going to go ahead and I'm going to write that up here to start my thing. Now the question is, these aren't x's and y's, they're not ordered pairs, but if I think about the ordered pair x and y, it goes in alphabetical order. X comes before y. So I'm going to write this as an ordered pair. I would go s first and then t. That's just a general rule of thumb. So s is going to be negative 2. I need to find what t is. So if s is equal to negative 2, I'm going to substitute it into either one of the first equations. I'm just going to go with the second one because the numbers are smaller. Doesn't matter. Just looks a little bit easier. So I'm going to say 3 times s, which is now we think is negative 2, plus 4t. That should be equal to 31. So I'm going to put that negative 2 in here for s. I'm going to pull out the s. I'm going to put in negative 2. And so this will be negative 6 plus 4t equals 31. Now I'm solving for t. Oh, let me apologize. This should not be here. Get rid of that. So I'm solving for t now. So I'm going to add 6 to both sides. And here I've got 4t. It's equal to 37. I think something clearly has gone wrong here. Let's just work this down though. So t, I think, is actually equal to, what's this going to be? 9 1/4. 9 1/4. Did I do something wrong? I don't think so. would be negative 10, 37, 9 and 1/4. It looks like I've done the right stuff. So let's go ahead and I'm really unsure about this answer, so I'm going to go ahead and check this. I'm going to check this by going back and saying, well, if I have 5s plus 4t equals 27, then 5, I'll take out the s and put in negative 2, plus 4. I'm going to change 9 and 1/4 into an improper fraction, which is going to be 37/4 is equal to 27. This is going to be negative 10 plus these 4's are going to cancel. 37 equals 27. And this is 27 equals 27. It works for this equation. Let's go ahead and try this for this last one. So I've got 3s plus 4t equals 31. So here I've got 3 times negative 2 plus 4 again times 37/4 is equal to 31. This is negative 6. Again, I'm going to do this off to the side here. The 4 over 1 times 37 over 4. These factors of 4 cancel, leaving me with 37. So negative 6 plus positive 37, does that equal 31? Well, yeah, it does. So 31 equals 31. Huh. I was really doubtful that was going to work out that way. So here I have my solution is negative 2 and 9 and 1/4. And I've checked it to make sure that's the right work. Example 2 is 3x plus 4y is equal to 6. And 5x plus 2y is equal to negative 4. After I'm finished writing that in my notebook, I'm looking here to see which one of these are either the same, coefficients are the same, or additive inverses. 3 and 5 aren't the same or additive inverses. 4 and 2 aren't the same or additive inverses. And here I've got 6 and negative 4. I never really look at the constants. So what I'm thinking to myself is this actually doesn't seem like I should be able to use elimination method. But in fact I can, because what I can do is I can multiply the entire equation by some number. The equation stays balanced, and if I multiply by the right number, what I will do is I will end up getting a coefficient for either x or y that are the same or additive inverses. In this case, I'm looking right here at the 4 and the 2. And I know that if I take 2 times negative 2, that will give me negative 4, which is an additive inverse to 4. So if I want to actually multiply this 2 by negative 2, I can multiply the entire equation by negative 2. It'll change all of the terms, but what it will happen is I'll end up having an additive inverse for that coefficient for y. So really what will happen here is I'll have 3x plus 4y equals 6. This one doesn't change. But once I multiply and I distribute that negative 2 to every term in the second equation, this is going to be negative 10x. This is going to be negative 4y. And this is going to be negative 2 times negative 4 is positive 8. Now what's tricky about this is a lot of students forget to multiply negative 2 times that negative 4. Or they forget one of these terms. You just make sure that you distribute that negative 2, or whatever you're multiplying the entire equation by, to every term inside that equation. So now I can see that I've got 3x plus 4y equals 6 and negative 10x minus 4y equals 8. If that's the case, I'll use blue here, these two now, the positive 4y and the negative 4y, are additive inverses. If they're additive inverses, if they're opposite, I add. Additive inverses, I add. So 3 plus negative 10 is negative 7x. The 4 plus negative 4 is nothing. Cross those out. And 6 plus 8 is 14. Divide both sides by negative 7. And x is equal to negative 2. Cool. So here I think that my x value will be negative 2. Let's go ahead and find our y value. I'm looking up here. Either one would work. I'm just going to go ahead and do the first one because I have smaller numbers and they're all positive. So I have 3 times negative 2 plus 4y equals 6. This is going to be negative 6 plus 4y equals 6. I'm adding 6 to both sides. This is going to be 4y is equal to 12. And here I've found, by dividing by 4, that y is equal to 3. Or so I think. So once we've done this, let's go ahead and check. And again, I'm going to have my green pen. And I'm going to check these. I'm going to check these by starting by rewriting each one of the original equations. So I'm going to have 3x plus 4y equals 6. I'm taking out the x's and the y's. I'm putting in the values that I found for them. So I think 3 times negative 2 plus 4 times 3 should equal 6. And this is then negative 6 plus 12. Does that equal 6? Yes, it does. And I'm going to put a check up here. I'm going to keep my original equation for this second one I'm checking. So I'm going to say 5x plus 2y equals negative 4. And this just helps make sure I don't make any silly mistakes. So I got 5 times negative 2 plus 2 times 3, and I think that is equal to negative 4. This is negative 10 plus 6, I think is equal to negative 4. And indeed, negative 10 plus 6 is negative 4 equals negative 4. And here I can put the check. And I know here now that, in fact, negative 2, 3 is a solution to this system of equations. Okay. So you can see what I'm doing here is I'm multiplying this second equation by the number. It's going to give me an additive inverse for these coefficients. And that's how I choose these. I'm going to hop down here really quickly to our last example, example 3. And you can see and write this in your notebook is 6x minus 3y is equal to 27. And 4x plus 4y is equal to 24. I'm looking at these and I'm thinking, between the coefficients for x, what would I multiply 4 by to get to 6? Oh, it's a fraction. That's going to not be really great. And here I'm thinking negative 3 and 4. What would I multiply one of those by? It's going to be a fraction. So in this case, what I'm going to want to do is actually multiply both of the equations by something. I'm going to go ahead and say this first equation, I'm going to want to multiply it by, let's get rid of the x variables here. I'm going to multiply it by 2. Because I know that when I multiply 2 by 6, it's going to give me 12. And if I do that down here, I'm going to multiply the second equation by negative 3. Now why do I choose negative 3? Because negative 3 times 4 is negative 12. If I say 2 times 6 is 12, negative 3 times 4 is negative 12, these are going to become additive inverses and eliminate. And that's really what I'm after here. So let's go ahead and distribute. I do that now so I don't forget any of the terms. So this is going to end up being 12x minus 6y is equal to 54. And the blue one, I draw the arrows so that I don't forget any of the multiplication. This is going to be negative 12x, that's the important part here, these are now additive inverses, minus 12y is equal to 24 times negative 3 is negative 72. And since they are now additive inverses of each other, these two coefficients are now additive inverses, I'm going to add the equations together. 12 minus 12 is nothing. Those cancel. negative 6 plus negative 12 is negative 18y. 54 plus negative 72. I have to actually subtract these. This is going to be 6, 1. This is 18. And this is going to be, isolate for y. Y is equal to negative 1. So I think y is equal to negative 1 here. I'm going to put that up here. My blank x. Y is equal to negative 1. And if I think y is equal to negative 1, I'm going to go ahead and substitute that back into one of the original equations. I'm going to pick the second one, just at random. They're all positive integers, so that's why I'm picking it, quite honestly. So this is going to be 4x. Let's go ahead and find what x is equal to. Plus 4 times times negative 1 equals 24. Here I have 4x minus 4 equals 24. Solve for x. X is equal to 28. Divide by 4. 28 divided by 4 is 7, and 4 divided by 4 is 1. So this becomes 1x is equal to 7. So I think now that the point at which these two lines, if they're in slope-intercept form, would cross, if I were to graph these, is 7, negative 1. I do want to check this one. So in your notebooks, check this with me. I'm going to have 6x minus 3y is equal to 27. Notice I'm pulling the original equation. Just prevents me from making a mathematical error. So 6 times 7 minus 3 times negative 1, I think, is 27. This is going to be 42 plus 3, I think, is 27. And we know that that's actually not 27. So somewhere we've made a mistake. Let's go back and check our notes for a second, or let's check our work. So we've got 12x minus 6y is equal to 2. I've got 12x minus 12y. This looks good. Cancel these. I've got negative 18. Oh, I found my error. So I go back and I'm checking over my work. I made sure that this stuff is good here. Everything is good up until this point. What I know that 54 plus 72 should be negative 18 here. So this is going to be a positive 1. Notice that that sign in that 1 is going to drastically change my answer. So let me just go ahead and do this over again. So then this would then be 4x plus 4 is equal to 24. Subtract 4 from both sides. 4x is equal to 20. Divide both sides by 4. And x should be equal to 5. Okay, so I'm thinking about this now. I'm going to go back. I'm going to change this. To 5. I'm erasing where I had checked the work, because I'm going to go ahead and I'm going to recheck this now. we think x should be 5 and y should be 1. So down here, I'm going to say 6 times 5 minus 3 times 1 we think will be 27. And so I have 30 minus 3 we think should be 27. And yes, we found the mistake. And let's just double check to make sure this first one is good. It works with both of them. So we found, and we were lucky to catch it on the first equation, but we have to make sure it works with the second equation too. So 4x plus 4y is equal to 24. And 4 times 5 plus 4 times 1 equals, we think, 24. That's 20 plus 4. There you go. And yep, it works. So for example 3, while we made a small mathematical error, it threw our answer off. We were able to go back and check by checking and correct that error. I think, if I can scroll down, that finishes our examples for today. Make sure you've got those in your notebook, and I will see you guys tomorrow.